might be hungry. But sincerely hope this might be an interesting topic during lunchtime. Yeah. Hi everyone. My name is Ziyang. I'm a PhD student from Northwestern University. And I'm here to pleasantly introduce the paper, A Decision Theoretic Framework for Measuring AI Reliance. Okay, so a lot of decisions today are made by human and AI, not individually, but collaboratively. The example can come from medicine, finance, or even criminal justice, and that's listed here. And so here is an urgency around understand how well people use the AI, because there are usually an interest in returning humans control over the final decisions. And there are also flurries of empirical works starting the human decision making with AI as assistance. And the goal of this study is complementary performance. They usually assume a pipeline where the human have some internal model of the data generating process, and they're able to use that to make a prediction. And they also have access to an AI prediction. So ideally, the human with AI's assistance can do either better than human prediction alone or AI prediction alone. So we might observe that if we want to make sense of these studies, we need to know the expected performance of the human alone, AI alone, or the human AI team together. We're hoping to see a scenario like this, where the human and AI have similar performance, but the human AI team have much better performance. We're not hoping a scenario listed below where the human AI team is worse than AI alone. So this analysis can tell us whether the human AI team achieved the baseline of complementary performance. But if we want to know whether we can do some following improvement to help the human AI team achieve better, then we need to know, is it even theoretically possible for human AI team to do better? And what is the room for our following possible improvement? And so to answer this question, we need to put the human AI team performance relatively to a best attainable performance. So if I told you that the best attainable performance is right over here, and we take the better between human and the AI team as the lower bound of our comparison, then we can say the human AI team performs very good in this scenario, and it achieves almost all the value of the best attainable performance. But if I told you that the best attainable performance is far on the right, then we can say there is still a large gap for a possible improvement. And after we knowing this, we also need to know what is causing this gap between the best attainable performance and the current human AI performance. And before we going deeper into our framework, let's take a look at what people are currently doing. They take a benchmark called the appropriate reliance, which is defined as the human adopts the AI prediction when it's correct and rejected when it's incorrect. But we found a problem of this. The first problem is the benchmark defined by this appropriate reliance might not be attainable because it's defined based on the perfection in hindsight. It doesn't account for some factors like whether the information provided in the decision-making task is able to help people to make these perfect decisions. And the second problem of this benchmark is that when we use the appropriate reliance to interpret what is causing the people to make the bad performance, it can lead to misleading conclusions because it confounds the error of using AI more or less the optimal, which we usually call reliance, with confusion about when to go with AI, which we'll call discrimination in our paper. So in our paper, we try to set up the expectation about what performance is possible for behavioral participants to achieve in a real-world experiment. And to do this, we will simulate a rational decision maker on the same experiments as the behavioral participants. And the rational decision maker will always maximize their expected utility based on Bayesian rationality. And we will use the expected performance of the rational decision maker as the best attainable performance. So here is the two contribution of our paper. We set up the best attainable benchmark using the expected rational performance, and we will call this a rational benchmark. And second, we show that using the rational benchmark, we can actually give better interpretation of where the human AI team fails. Okay, so these are all the high-level intuition of our paper, and then I will go to more details of how to use our framework. So first, let's take a look at our assumption about the rational decision maker. So upon each decision-making trial, the rational decision maker will have access to the human prediction and AI prediction, and they're only able to choose an action between adopting the AI prediction or the human prediction. Oh, so sorry, where I mean the human prediction is like the human's action before they seeing the AI. And their action will be evaluated by a payoff function. And we assume that the only goal of the rational decision maker in this decision task is to maximize the payoff defined by this payoff function. And to fulfill this goal, the rational decision maker will follow the Bayesian rationality to do this. And they have a prior belief, which is defined by the experiment setup. For example, the rational agent can know, like, from the overall of this decision-making task, what's the overall probability that the human will be better than AI. And the rational agent also have access to some signal. The signal can be the question description, and with realize the human prediction and AI prediction. And probably also have some other signal like the explanation to the AI's prediction. And the rational decision maker will update their belief based on Bayesian rule. And they will get a belief, like, for example, on this specific question, after knowing the signals, what's the probability of human being better than AI? And they will take an optimal action based on their posterior belief. Okay, and like I said before, in our framework, we use the expected performance of the rational decision maker with access to the signal on the specific decision trial as the best attainable benchmark, which we call Reliance benchmark. And similarly, we also define a rational baseline, which is an expected performance of a rational decision maker without access to the signal. And in this scenario, the rational decision maker can only rely on their prior belief of whether human or AI is doing better, and to always take a fixed action, to always adopt human or always adopt AI along all the decision trials. So this rational baseline is equivalent to the better performance between human alone and AI alone, which is the same with our definition about the complementary performance. And we use the difference between this rational benchmark and baseline as the value of a complementation, which describes the best improvement we can expect from incorporating a human AI collaboration compared to just using a single row of human or AI alone. And using the rational benchmark, we can show that how much the behavioral participants lost compared to this best attainable benchmark. And we also show that our framework can give better interpretation about where the human AI team fails. And our framework can set up the behavioral loss into two parts. We use a benchmark called the mystery line benchmark, which is defined as the expected performance of rational decision maker, but they are constrained to have the same reliance on AI. And by reliance on AI, here I mean the probability of the decision maker to go with AI when the human and AI disagree. And this mystery line benchmark represents the best attainable performance for a certain behavioral reliance on AI. And using this benchmark, we separate first part of the loss, which is called the reliance loss, and it's the error of over or under relying on AI. And the second loss is the discrimination loss, which is a loss of incorrectly choose when to go with AI. Yeah, and there is uncertainty in all the quantity on our framework, and all the point estimates can be written in distributions like this. Yeah. And we demonstrate our framework through a highly cited paper. We identify the issue about their experiment design, and also we give new interpretation of their results. And today I will give you an example of our demonstration on Bessel et al. 2021 paper. In their task, they choose a multi-choice question with only one correct answer. the payout function. And they have 4 experiment conditions, a baseline without any explanation, and an explanation to explain the top one evolution, and an explanation to the top 2 evolution, and also an adaptive function to choose between top explain 1 or explain top 2. So let's first take a look at the rational benchmark and baseline. We found that the value of computation is pretty good in this decision-making scenario. Rational decision makers have about 39% increase when they have access to the human. When they have access to the human or AI together, and we show that this is a good scenario to deploy a human-AI collaboration system. But we also found that this is not always true. It's true across all the studies we do demonstration now. If you want to take a look at that, please refer to our paper. Yeah, and then we put the behavioral performance, which is a actual human AI's performance in our scale. And we found that despite they achieved the baseline of complementary performance, there is still a large gap between the benchmark and behavioral performance. So only a small fraction of value of computation is achieved. And then we put in the mystery line benchmark to explain where human AI fails, actual human AI team fails. We found the main source of loss is discrimination loss. And this suggests like we should try to improve the presentation of signal, but not necessary to calibrate the overall trust on AI. Yeah, and I will wrap up with a few takeaways. So many studies on human reliance on AI are failed to set up a rigorous skill to interpret the human behavior. So it's hard to improve the pipeline based on their results. And our paper, we offer a rigorous framework for evaluating human AI by providing skill of rational benchmark and rational baseline. We can check the value of complementation before we deploy the human AI collaboration system. And by decompose the behavioral loss into reliance loss and discrimination loss, we can check the reliance loss independently from other deconfounders and give interpretation of where the human fails. And we see this as a step toward the rigorous science of human AI collaboration. Okay, thank you.
So quick question. We saw like several interventions to reduce like reliance loss, but what will be an intervention to reduce discrimination loss?
Oh, yeah. So the discrimination loss is defined as like when people have the same reliance on AI, the difference between them must be they accept AI and different instance. So in our framework, we analyze like people have a good overall trust on AI, which means that they know, okay, what's the overall probability of AI being correct, but they just don't know like where in which instance the human AI would be good. So like this can imply to help improve the presentation of the signal. So like we can like show probably some information in the signal they are calibrated to the ground truth, but they're just not perceived by people. So like it can be like something like we should stress on some good signal in our information design.
Yeah. Okay. You touched on this a little bit, and I was wondering if you could give some description or qualities of the types of decisions that this framework works for. Like I know you mentioned one, but do you have some like summary of the types of decisions?
Oh yeah. Yeah, we see this as like pretty have a wild application area because like as long as you can formalize your decision-making task into one have payout function, have a data generating process, have a signal design. You can use a framework to analyze the best attainable performance and decompose your behavior loss. So I also think, yeah, I admit that there are some questions that cannot be formalized in our framework. For example, like there are some like the subjective words, like let human to judge, okay, whether this is like a positive review or negative review of a hotel. Like you cannot know like whether the ground truth is. Also, there are also some cases where the ground truth can be censored. For example, like for criminal justice, some decision tasks, like if you decide to put someone in the jail, you cannot know the ground truth from that person. It's like whether they will be rearrested in the future because they already put people in jail. Yeah. So yeah, people should be pretty clear about their payout function and be very cautious about that when they use our framework. Yeah.
Thank you.
Thank you. That concludes the session. Let's thank all the speakers for a great presentation, for a great presentation.
Thank you.
We have lunch now.